first of all, let me start by introducing myself. My name is Yavor Dimitrov. I'm a technology team lead here at Scalefocus. I've been programming professionally for 10 years and breaking computers for more than 20 years now. So this presentation is part of our Tech Savvy series. So Tech Savvy series are hosted by Scalefocus. This is the second season of the initiative. Under it, we would hold events on various technology topics. The speakers are our colleagues at Scalefocus from various fields. So if you want to learn more about it and see future sessions, stay tuned on Eventbrite or other social networks. Also, before we jump into the presentation itself, I would like to cover some housekeeping items. So first of all, the session will be recorded. I'm legally required to tell you that. At the end, there will be an interactive Q&A session. And this session will be done in a platform called Slido. So you can either join at the link below using the TechSavvy hashtag, or you can just scan the QR code. You will have a chance to ask your questions at the end of the presentations. We will cover those. So what is the agenda of this presentation? The agenda is basically we will start by covering the solid principles of object-oriented programming. We will brush through those. We're not going to go into detail about all of them and cover them extensively. So we will learn about, in my opinion, which one are the most important one. After that, we will focus more on the dependency inversion principle. And we will, in order to cover that, we need to talk about what is abstraction, what is dependency, and how to invert them. So let's start. The solid principles of object-oriented programming. This is basically the first development 101 or object-oriented development 101. So I'm not trying to basically cover subjects that are for beginners, but I want to at least cover all of them and tell you about why those are, some of them are more important than others. So let's just start by describing each one of them. So single responsibility, basically this is a principle that states that your object should have only one responsibility and one responsibility only. So basically, don't send emails from your database driver. Open-closed principle states objects should be open for extension and closed for modification. The main idea is that if someone can do something with your code, they probably will. So you need to prevent that when creating base classes and base types that are intended to be inherited. List of substitution, basically the idea of that principle is you should be able to replace all instances of a super type or a base type with an instance of an inherited type without breaking your application. Interface segregation is basically don't create big interfaces. If you need to add something to an interface, think about everyone that has to implement it. And if there are too many objects that implement that interface, it's probably better to segregate that into a new interface and selectively implement that one. And dependency inversion principle states that higher level modules should not depend on lower level modules. Instead, both should depend on abstractions. And the second part is that abstractions should not depend on details. Okay, now that I have impressed you with my first grader knowledge, let's talk about more what I see in my experience. So usually those are put together by Uncle Bob or Robert Martin. So they're designed as guidelines that will help you basically reach heaven and write the best code possible. However, in practice, most of the time you don't need all of them. So single responsibility, I believe, is very important, since basically nobody likes to scroll 20 screens in order to reach a line that he's looking for. But also single responsibility is easy to understand. Pretty much if you're working with the code, you probably will figure out if the code you're looking at has a single responsibility or more than one. So I believe it's important, and you should definitely use it. Open closed, usually this applies to when you have a lot of subclassing or a large tree of inheritance, which usually, at least in my experience for the last couple of years, rarely we need to have a lot of inheritance in our code. So usually we have one or two subtypes or something like that. There are some applications probably that require more subtyping, but in my experience, and my experience is primarily in .NET, I don't see such cases. So list of substitution, usually as well as open close, it requires your code to rely heavily on subtyping. So if you have a couple of inherited classes and not large tree of inheritance, also you rarely have to think about it. Interface segregation, it's grayed out just to add drama. It's usually also important since it's similar to the single responsibility. Yeah, and the last is dependency inversion. So that's my favorite principle, and I believe that's one of the most important. The idea is if you properly apply dependency inversion, you can split your application in small clusters of related objects and packages. And no matter how bad the code inside that cluster is, there is no chance this code could break other parts of your application. So let's talk a bit more about the dependency inversion principle. So first of all, in order to talk about the dependency inversion principle, we need to talk about abstractions. So what are abstractions from the standpoint from the object-oriented programming perspective? So usually everything in our code is an abstraction. When we have a user or a developer object in our code, we don't have actual developers living inside our computer. We have a data structure that represents something about that developer that's important to our application. So for those of you, I doubt that there is anyone, I'm not trying to be super funny with that joke, but I believe it represents the example great. So usually there is a saying that the developer is an organism or a system that converts coffee into code. And basically, if you want to implement such an application, how would you go about it? You will create your coffee class, you will create your developer class, and you will create your code class, and you will write something like the code below. So this is great. You're already using abstractions. So, but since all of your code is abstractions, this system is not because all of your code is abstraction, but however, this system is kind of inflexible. So you cannot replace components or different implementations of the same system. So what you can do with that system is basically introduce another layer on top of that. And basically those abstractions are generalizing about your objects. So instead of calling the coffee a coffee, or not calling it, but wrapping it in an object and calling it input that can hold coffee within it, and instead of having developer that's called developer, wrapping it in an object called system, and of course your code wrapping it in an object called output. So you generalize about those terms or those objects, and this makes your system a bit more flexible because you can use the exact same code but have different results. So for example, if you give the developer a pizza, maybe they will create some documentation for you. So, and you can see in both cases, having coffee and having pizza, the code is actually the same. So we don't change the code. Now that we have talked about abstraction, let's talk a bit more about dependencies. So what's dependency in object-oriented programming? Well, usually dependency is a reference to something. So in your C# code, that will be your using statement. So if you have a using statement to some namespace, you depend on that namespace and the objects within it. So what this leads to is, you can see on the chart on the right, basically, that's a normal structure of an application. You have a main module, which usually all programs start with a main method. This main module could also be your web application and so on, but I will try to keep the examples simple to not add additional noise to that. So all programs start with the main method. That main method creates an object and calls one of its methods. That object in turn creates another object and uses its functionality and so on until you run out of stack memory. However, what this leads to is sometimes when we have to change part of our code, which is lower in this call tree, if we don't use abstractions, changing a code in a lower level module, let's say module 3, will lead to changes in module 2, and this could potentially lead to changes in our main modules. And this is without using any abstractions. So what this leads to is basically all of the lower level modules or all of our implementation details, when they change, all of the higher level modules will also have to change at some point. This also prevents us from switching different implementations. So instead of using one data provider, using another makes it a bit harder to implement, or basically requires a lot of rewriting in our core functionality. And also the code gets, well, basically impossible to test since nothing depends on abstractions. Usually that's something that's widely used. All of our dependencies are injected as interfaces, so we can mock them and replace the different implementations with mocked implementation. This way we can isolate our modules and run them as single units. So how would this standard normal flow of dependencies, how this could be inverted? Well, by introducing abstractions for lower level modules and making all of the lower level modules depend on those abstractions, and as well as the higher level modules depending on the same abstractions. So let me go back a slide. So if you can see here, there is a direct path between the main module and module 4. So if you follow the arrows, you can basically go to module 4. Well, let me use a pointer for that. So if you go from the main module and follow the line, you can go to module 4 just following the arrows. And this means that there is an indirect dependency of your main module on module 4. So if you however use abstractions and make both the higher level and the lower level modules depend on those abstractions, you can see that there is no way for your main module to reach something in the lower level modules, because there is no direct connection, or indirect for that matter. What this allows us to do is basically isolate the low level code changes. So there is no way a change from a lower level module to go to our main module. We can replace those, giving us higher, more modular applications. And also we can also replace those implementations with mock implementations that could be mocked and used for unit testing or some other purposes potentially. So in order to demonstrate that, I have made a small example that demonstrates how we usually do things. I primarily see it in .NET, but it's not an exception. So I've seen it in other technologies as well. And I will use .NET as an example, but pretty much all technologies that will that use project-based or package-based development are going to have a similar experience. So first of all, I would like to, this is not going to be a live coding session. This will be just a demonstration. So I would like to walk you through what I'm trying to demonstrate here. So I have decided to create a sample application, basically application for making online reservations. So the app part is basically what we run. In the specific case is a console application. We have our services layer or our services domain, and we have decided, since services could also take care of sending data to your database and so on and so forth, we have logically separated the reservation part of application into a reservations package. And we also added 2 different providers for reservations in order to demonstrate how you can switch between those or use them in combination. So yeah, the application, all of the code is basically, it has no dependencies other than the .NET framework. I have decided to eliminate all of that noise, all of those packages, to make it as clear as possible. So let's walk you through a couple of different scenarios. So usually this presentation is called "These Abstractions Offend Me." So this here is the offensive part. So usually when we write applications, what we do is putting our interfaces in the same project as our implementations. And this is if we treat objects as modules, that is okay, because our high-level objects will depend on those interfaces, and those implementations will also depend on those interfaces. So you can see that logically we can still treat it that way. So we have our high-level module, which is services. We have a low-level module, which is implementation of those different reservations. And we have our abstractions, which are our interfaces and other data contracts. So what this creates is logically, those are 3 separate concepts, but physically those are stored in just 2 packages. So your abstractions are contained within your lower level module. So what this makes harder, imagine a larger project where you have a separate team that has to maintain the booking manager, and you have another team that maintains your Airbnb manager. And those are large projects that require a lot of work. So those are separate teams, but if they work on the same project, they have to contribute to the same Git repository. Or even if it's just a single Git repository, they will have to push changes in the same place. So physically, the code itself is not isolated. Maybe logically, and logically is not always the best thing to do. So that's why parallel work is harder, since you are working in a centralized locations, and sometimes you can have multiple teams introducing conflicts when making changes. So another side effect of that, or another drawback of doing it this way, is basically having all of your implementations together with your lower level modules. What this does is basically all of the booking manager dependencies, let's say it depends on 10 NuGet packages or additional binaries, you will have to drag those together with your reservations assembly. And also, you will have to drag all of the Airbnb manager implementations with that or binaries. So let's say at some point you decide that you will not use Airbnb manager and you just disable that, but unless you remove the code, the dependencies and all of those binaries will end up in your application. So you can imagine how at some point, if you have a lot of different application domains like reservations, database storage, caching, so on, and having multiple implementations, you can see how much this could add up to your overall package size or application size. So one other drawback of that is there's a higher chance of your abstractions to leak, since your implementations like Booking Manager and Airbnb Manager, if that's the case, putting them together with the interfaces, in any case, you have to make them public. So in order to unit test them, you have to make them public so you can actually write unit tests for those, or you have to go through very complicated ways of encapsulating those, so they are not actually visible outside of that repository, or not directly creatable from outside. If you don't do that, however, you can see that since services has a reference to reservations, our reservation service can directly bypass those abstractions and directly call code from our booking manager. So I need to list a benefit for that, since that's how I was taught. So a benefit of that would be that you would just have 2 packages instead of having more than 2. So one other way that you can organize your code is those are basically the same classes, but instead of your interfaces or your abstractions living in your lower level modules, you put them in your higher level modules. So you move the interfaces in the services project. And what this does is it allows us to selectively carry different implementations of the different reservation providers. So this way we have one project or one package for our booking implementations, one package for our Airbnb implementations. And when we build our application, we can decide, okay, do I want to use just one of those, both of them, or the other one? So this allows us to basically be able to work in parallel. So if this is a separate binary, it's a separate project. So it could even be a separate Git repository that you could have separate teams working on it. You could even have different processes, software development processes, different architectures, and so on. So don't think about this as a single class, but think about it as a project or a module, which could be a single class, or it could be an entire application. So this eliminates most of the drawbacks, but introduces another one. So now, instead of your services layer being able to directly reference implementations, it's possible for your lower level modules or your implementations to reference a higher level module. So this is against most of the software developers' religion. So usually I don't recommend this approach as well. But yeah, the benefits are still there. If you just want to separate your work into different repositories, that's one way to do it. And the best way, which I believe is the proper way and how everything should be done, is basically treating all of the logical concepts as physical ones. So when you build your dependencies, you have your services containing only your services, making those services depending on your abstractions, and moving those abstractions into a separate project package, library, whatever you call it, and moving all of your different implementations for those providers into separate packages as well. So right now you can see on the left you have your physical separation of those concepts, and on the right you have your logical. And this way, no detail can reference a high-level module, and no high-level module could directly reference implementation details, because this abstraction layer here actually is blocking access to the other side. And this allows us to basically disconnect the two sides of this abstraction layer and replace them with something else, and still have a working application without changing too much code. So this adds another drawback. If you have to be OCD about it, basically between all two modules or two packages, you have to put a layer of abstraction, and you can see how this from two assemblies it grows into 4. And if you have to do this for each project, that will generate a lot of unnecessary abstractions. And yeah, as a drawback, this introduces a larger number of packages or projects. But yeah, you still keep the benefits from having being able to work in 2 separate locations, and also you keep the benefit of you can take one of those parts and place another one in its place. So I believe I started by sharing how I will walk you through a project, and I talked for, let's say, 20 minutes about it. But yeah, this currently described the project that we're going to take a look at. Just let's check it here. So first of all, I would like to start with the standard way. Usually this is done in, that's how developers start to learn programming. I've seen it in pretty much all of the software academies that are having some .NET courses. Well, those are not my inverted dependencies, so I'll probably have to check my other diagram. So yeah, those are the standard. Don't mind the wrong naming convention. So you can see, let me just walk you through what everything means. So I have simulated a couple of NuGet packages. So if you imagine this Airbnb API is a library that's provided by Airbnb, and this booking is the same for booking. And those are provided as NuGet packages. The idea is not to the code to not be dependent on anything. And yeah, that's why those are called simulated NuGet packages. You can treat them as actual NuGet packages. So how would we implement a system, the same system that I walked you through? So though that I don't recommend using Microsoft diagramming tools, graphing tools. Those are very slow, but I had to do it since I wanted to show you this in Visual Studio. So again, you can see the same structure as in the presentation. We have our application. It calls our services layer that initiates the reservation. You can imagine here having similar modules lower, maybe our data modules that will actually store something in a database, that will cache something, that will send emails to users. But in terms of, for the purposes of these demonstrations, those are not important. Another one here is, since we at some point we need to register all of our dependencies, and you probably have seen that all of the applications that are using dependency injection, your highest level module usually depends on everything, just so it's able to register all of the dependencies and configure them. So that's why I have added these modules here, which its sole purpose is to register implementations for our abstractions. But if we remove it, you can see we have a pretty standard application structure. So if we go to our standards implementation, let me do something like that. So you can see my app lives here. This is my modules assembly. We have our services and we have our reservations. And our reservations are having reference to those two NuGet packages that I have invented. So let's try to run that. Sorry if I seem a bit slow, but I'm looking this on a screen that's 2 meters away from me, so it's not easy to click on things. So this is my application. What you basically see is this is my module registration. You can think about this as the code that initializes your dependency injection container. So we get an instance of that service. We make a call. That service, that reservation service. Well, let's try. Wrong button. So if we go to the implementation of that service, you can see that this service calls our reservation manager, which handles our reservations. It makes a request to get a new reservation, and it returns it. Usually this here, you probably will have a lot of database code, caching code, some emails being sent left and right, but those are actually, and if you try to go to the implementation of that class, you can see that we have two different implementations. This is our Airbnb manager, which implements this reservation manager abstraction, and we have the exact same thing about our booking manager that also implements the same abstraction. And as well, you can see those are my simulated NuGet packages. We have a booking API in this one, and we have an Airbnb API in this one. So let's just save that before we and maybe close that. So you can see here, I can, let's choose the proper app, however. So this will be my app. If I run the application, maybe I should move it to the other screen. But yeah, you can see that I got a reservation from Airbnb for myself. So I have requested that user. We didn't know what happened. That's what abstractions are for. So we just call it, make me a reservation. It somehow, I don't know how, it chose to do an Airbnb reservation, and looking at that code, you should be able to figure this out. So basically right now, what we have here is every time we try to use our reservation manager, we have provided it with those specific implementation details, thus making it basically always make reservations with that. But we can easily switch to that by just changing those implementations. You can see that I don't have some package references. I'll quickly add those. I'll try to run the code again, and I would like to show you what would be the output of that in terms of packages. So let's run that again. Okay, maybe I have added a reference to the wrong assembly. Let's just check it out. So I'll just okay. So we have our services depending on reservation, and this is depending on the two. Okay, that seems about right. Okay, so I don't know how it managed to find reference to those abstractions, but maybe it's this one. Okay, I don't seem to be able to figure out what's going on with this code. Is this the proper? Yep, it is the proper application. It doesn't have any dependencies on any of those abstractions. Sorry for the technical difficulties. I have tried this a couple of hours ago and it worked, but maybe I have added the reference to the wrong assembly. So let me try something else. So basically remove that. I'll try to recreate the dependencies. So just okay, so let's try this again. Let me just comment the same code out. If I don't manage to try it on the first time, we will go to the second part. I'll make sure that this works properly in the Git repository. Okay. And this is what happens if you try to keep the same naming conventions. However, so this is my program. It should depend only on my services. Okay, that should be it. And yeah, it of course needs to be able to depend on those, so we can register. So if I go to this here, try to uncomment that line again. And try to run the application again. Let me find my window. Okay, so you can see that we have switched the implementation. So instead of having Airbnb reservation, we have a booking reservation. So let's switch back to that. I'll just want to verify that everything I've done is working still. Okay, so it works properly. So yeah, what I wanted to show you, however, is basically even if we do it this way. So let me close that. When we have our abstractions and our implementations in the same assembly, those, in order for this package to be built, it needs to bring all of those dependencies here. So no matter if our application is using that or not, that manager, those packages will always be in our output. So let me try to show you this. Oh, I don't believe you can see it, but maybe we can take a look at it here. So you can see our output folder. In our bin folder, we have all of those different dependencies. No matter if we use them or not, they will always be there because that's how our projects are referenced. So let's just go back one level. I have created here the exact same code. So those are the exact same objects. You can see that those are completely identical, even those ones. Let's see here and what I have open. So you can see those two files are exactly the same. Even the namespaces are the same. But instead of separating all of those files into folders in my project, I have actually moved those into other projects. So, well, that was the wrong diagram. Again, I have these app modules which should depend on everything in order to be able to use it properly. But here, if I remove it, you will see just the dependencies on the project. So you can see my application depends on the services, the reservation. The services depend not on specific reservations, but depend on abstractions. And both of my implementations for those reservations depend on the same abstractions. So what this allows us to do is basically create multiple different applications that selectively choose what they want to include. So it's the same scenario as in the application that I just showed you. Let me just remove all of those additional things so I can show you just the properly implemented projects. So you can see I have decided I want to create an app, but this app will only work with one reservation provider. So what I have created is just added references to my services because that's how reservations are made, or if I want data storage and so on. I have added a reference to my reservations abstractions, and I have added a reference to Airbnb. So in this application, there is no direct or indirect reference to any of the booking providers. So no matter how long you expand those, you will never see reference to our booking project. And what this leads to is, I will build it and I will show you the output. You will probably not see anything different than what I showed you the previous time. So let's open this one, go to the bin folder. And you can see that basically we have the exact same code, but our output or our application, our binary files or our compiled packages are significantly less. And you can imagine how this is basically an application with 3 or maybe you can call them 4 components. But usually, I doubt that in the real world, those components will be enough for even the basic, even a basic application. So you can imagine how all of the applications that we develop usually go with a ton of dependencies, and sometimes those are even gigabytes of data, and not all of those are often not all of those are used. So basically, that's the demo. The code will be available on a thing called GitHub. So allow me to show you something, since one other benefit of properly organizing your abstractions into separate applications comes with an additional benefit. So usually as a senior developer, I often have to do request reviews, pull request reviews, and usually as a senior developer, I often scroll through those and not read them in too much detail. However, doing it this way, at least you can still keep the quality of the code, or at least the quality of the architecture in your infrastructure, without having to go into too much detail in your code reviews. As I mentioned, using proper abstractions allows you to isolate a corner of the application and basically give it to anyone, or in that case, we give it to the intern. So this is, I believe, yeah, this is the inverted abstraction, and this is usually the standard way we implement those. So what you can see here, this is a pull request. What the intern did is they just changed. This is our service. Usually this changes with anytime our business logic changes. So this is one of the most oftenly modified classes. So as a senior, I usually look if they have properly created their dependencies. I see a private read-only that looks okay to me. It's injected in the constructor, it's initialized, and it is used afterwards. So that looks okay, but if you really know your project, which even in the best cases, sometimes there are corners of your projects that you don't know. If you look at this is our Airbnb API implementation, which is something that should not be possible, or not, it is possible, but it should not be referenced from our reservation service. So all of those functionalities that this API provides should be accessed directly through the reservation manager. And there is no indication. So if you can imagine this being a complex class with more dependencies than what you see on the screen here, it's very easy to miss such change. And basically you will go here and you will approve the pull request. I cannot approve my own, can I? However, if you use the second way and basically use the properly separated abstractions, you can see that instead of changing one file, which is actually the exact same change, so they have again added this API, they have added it to the constructor, initialized it, and did some changes. You can see that other than this change, they have made a change to our project file, which usually when I make pull requests or code reviews, I usually check if they have made changes to our to the project files. If there are changes here, I definitely would like to know what is changed. And you can see that this is my services assembly, which usually should depend only on abstractions. And now it depends on detail as well. So usually when I see something like that, I don't even, if I see a project file here, I just click on that, take a look at this. And if it's wrong, I don't even go to the other part of the code, and I directly reject the pull request or request changes for that matter. So that's, I believe, in practice, this is one of the most useful things about adding unnecessary projects. Those might seem unnecessary, but in those cases, they usually are quite useful.